Okay, today we have the topic line integrals. That is when we considering a vector function that is passes through a line, or the integration of that vector function along through a curve who's called that integration is called the line integral. Before going to that line integrals, okay, we want some topics or some terms, that is closed curves, simple closed curves, open curves, smooth curves, etc. First we want to discuss closed curve. In the plane, a closed curve is a curve with no endpoints and which completely encloses an area. That is a curve which is closed when it has no endpoints and which completely encloses an area. Next, simple closed curve. A connected curve that does not cross itself and ends at the same point where it begins. That is, when a curve is called a simply closed curve, a connected curve is called a simply closed curve when it does not cross itself and whose endpoints, that is its starting point and ending points, are the same. Okay, examples: ellipse, circles, polygons, etc. Here we have some pictorial representation of curves. That is, first one is a simple curve because it's simple, which does not cross itself, so it is simple but not closed. Okay. Second figure 2 is a simple but closed curve. That is, it is a simple closed curve. And third one, this curve, consider this curve. This curve is cross itself and whose endpoints are different. Then this is a curve that is not simple and not closed. Fourth figure, it is a closed curve, yes, whose endpoints are same. Suppose the curve starts from here and ends on that same point, and but we consider this curve, it's going through this and it crossed itself, so it is a closed curve and that is not simple. Okay, then we have smooth curve. A curve C is smooth if it is continuously differentiable. Listen, if it is continuously differentiable at every point on C. That is, when a curve C is smooth, that is that curve is continuously differentiable in every point on that curve. Okay, that is suppose the curve is f, then whose derivation f dash is exist and f dash of x is not equal to 0 along that curve. Here we have two examples. First one is a curve which is smooth, second one is a curve which is not smooth. Okay, then we have the topic line integrals. First we want to discuss line integrals in the plane, then we want to move line integrals in the plane. In the same way we want to discuss the parametric representation of that curve. Okay, then first line integrals in the plane. Okay, let f equal to vector f equal to f of xy I cap plus g of xy j cap and the two-dimensional smooth curve C given by r, that is vector r equal to x I cap plus y j cap and dr equal to dx I cap plus dy j cap. Then the line integral of f along C is denoted by integral over C f dot dr, where C is the smooth curve, that's equal to r equal to xi plus yj. Suppose x is equal to xi plus yj, then dr equal to dx I cap plus dy j cap. Here f is the vector function, that is f equal to f I cap plus g j cap. Here only have two coordinates x y because we considering the plane. Okay, line integrals in the plane. Then taking the dot product of f and dr. Okay, that is taking f dot product of f and dr, we get integral over c f dot dr equal to integral over c f of xy dx plus g of xy dy. Here f of xy and g of xy are the components of vector function f and dx and dy are the components of dr. Okay, next we want to discuss, suppose the function x and y or the coordinate x and y are present in some terms of function, that is parameter t, in terms of parameter t, that is if x is equal to x of t, y equal to y of t and z equal to z of t. Now here considering z equal to 0 because we are considering only in the plane, line integrals in the plane. Okay, x is equal to x of t, y equal to y of t and z equal to z of t of parameter t, a less than or equal to t less than or equal to b, that is a t varies in between a to b. Then instead of x, here the vector function f, instead of x we substituting x of t and instead of y we substituting y of t, then the vector function f become f equal to f of x of t y of t I cap plus g of x of t y of t j cap. Okay, similarly the curve smooth curve r become c equal to r of t equal to x of t I cap plus y of t j cap, which implies d of rt. That is d of r of t equal to r dash of t dt. Here r dash of t is the derivation of r with respect to t. Then taking the dot product f dot to r, then the line integral become, the line integral of f along the curve c is integral over c f dot dr, that's equal to integral a to b. Here a and b are the domain of t, that is t varies from a to b. F of r of t dot r dash of t into dt. Note this equation, which is the equation of line integrals in the plane. Okay, now we want to move the line integrals in the space. We have the set coordinate also, that is let f equal to f of xyz, that's equal to f of xyz I cap plus g of xyz j cap plus h of xyz k cap. Here we have k cap. Okay, and the three-dimensional smooth curve given by r of t equal to x of t I cap plus y of t j cap plus z of t k cap, where t varies between a to b. Then the line integral of f along the curve c equal to integral over c f dot dr, that's equal to integral a to b f of r of t dot r dash of t dt. That is the line integral of space. Note this equation, which is the equation of line integrals in the space. Okay, now we can also write the line integral of vector field as a line integral with respect to arc length. That is, we also represent line integral in terms of arc length. That is integral over c f dot dr equal to integral a to b f dot tds, where t is the unit tangent vector. Suppose r is the position vector, then t, unit tangent vector t equal to r dash of t by norm r dash of t. This already we studied in our previous classes. Okay, then line integrals with respect to arc length, we can see that the second form is equivalent to the first form given above. That is, we discussed it, that is line integral we can represent by the arc length in terms of arc length. Then integral over c f dot dr equal to integral a to b f dot t ds. We know what is the expansion of t or expression of t, that's equal to integral a to b f of t dot r dash of t by norm r dash of t into norm r dash of t into dt. Cancelling norm r dash of t, then we get integral a to b f of r of t dot r dash of t dt. Okay, next we have the work done. That is the equation of work done is same for the line integral. Okay, but here the vector f is the force vector, that is the the work done by the force vector f along the curve c r of t is total work done w equal to integral over c f dot dr. Here f is the force vector and r of t is the curve. Okay, c is the curve and r of t is the expansion. That is total work done w equal to integral over c f dot dr. Then we have a remark. Note that the line integral is a scalar, not a vector, because we take the dot product. That is, we already studied that the line integral expands, that is integral over c f dot dr, the dot product of two vectors. We know the dot product of two vectors become a scalar quantity. That is, line integral is a scalar, not a vector. Okay. If the path of integration is a closed curve, then instead of integral over c f of r dot dr, we also write closed integral over c f of r dot dr. Suppose our path is closed, then the integral over c f of r dot dr, we can also write closed integral, that is the symbol of integral and a circle, that is read as closed integral over c f of r dot dr. Here c is a closed curve. Okay, then we move to the some examples or question sections. Listen, first question. Compute the line integral over c y square dx minus x square dy along the triangle whose vertices are 1 0 0 1 and minus 1 0. That is, we want to find the integral over c y square dx minus x square dy, that is the line integral. Okay, along the curve. Here the smooth curve is the triangle and we given the whose vertices are 1 0 0 1 and minus 1 0. Okay, now listen this figure. We take the points minus 1 0 here, 1 0 here and 0 1 here in the xy plane. Okay, a equal to 1 minus 1 0, b 1 0 and c 0 1, and joining them, then we get the triangle, that is the curve triangle, that is ABC is the curve C. Okay, then the integral over C, which means the integral over AB, integral over BC, integral over CA. Instead of we finding integral over C, we want to find integral over AB plus integral over BC plus integral over CA. and here given 2 points and that joining we get a line. We know suppose x1 y1 and x2 y2 are the 2 points, and the equation of the line that joining the that 2 points is equal to what is y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1 in the plane. Suppose it is in space, we have z minus z1 by z2 minus z1. Okay, now start the answer. Here the curve C is the triangle of vertices 1 0 0 1 and minus 1 0. See the figure. Okay, we want to find the line integral along the curve C. Here C is the triangle, then the line integral over AB, BC and CA. First we consider the line AB. Okay, here AB is the x-axis. In x-axis y equal to 0 and x varies from minus 1 to 1. Then along AB y equal to 0, then dy equal to 0. Then integral over c y square dx minus x square dy equal to integral minus 1 to 1. That is the variation of x in the x-axis. Okay, minus 1 0. Instead of y we substituting 0. Instead of dy we substituting 0. Then we get the line integral equal to 0. That is the integral over AB becomes 0. Then we want to check integral over BC, integral over CA. Okay, then along BC, equation of the line BC equal to y minus 0 by 1 minus 0 equal to x minus 1 by 0 minus 1. After calculation we get y equal to 1 minus x. Y equal to 1 minus x, then dy equal to minus dx. Then integral over c y square dx minus x square dy equal to integral 1 to 0. That is here in the BC line x varies from 1 to 0, y varies from 0 to 1. Okay, we changing all terms into in terms of x. So integral over 1 to 0, instead of y we substituting 1 minus x, that is 1 minus x the square dx plus instead of dy we substituting minus dx. Then we get integral over 1 to 0, 1 minus x square dx plus x square dx. After calculation and solve, we get integral over 1 to 0, 1 minus 2x plus 2x square dx, and integrating 1 2x and 2x square, we get x minus x square plus 2 by 3 x cube from 1 to 0. After substituting the values 0 1, we get 0 minus 1 plus 2 by 3, then we get 1 cancelled and 2 by 3. Here we have minus, that's equal to minus 2 by 3. That is the integral over BC, we get minus 3. Then we want to check integral over CA. Okay, along CA, the equation of that line CA equal to y minus 1 by 0 minus 1 equal to x minus 0 by minus 1 0. We get y equal to 1 plus x. Then y equal to 1 plus x, then dy equal to dx. Then integral over c y square dx minus x square dy equal to integral 0 to 1. That is the x, here x varies from 0 to minus 1, y varies from 1 to 0. We changing all terms in terms of x, then we get integral 0 to minus 1. Instead of y we substituting 1 by x, that is 1 by x the square dx minus x square. Instead of dy we substituting dx, that is x square dx. Then after calculation we get integral 0 to minus 1, 1 plus 2x dx, and then integrating 1 plus 2x with respect to x. Okay, then we get x plus x square from 0 to minus 1, that's equal to minus 1 plus 1 minus 0, that's equal to 0. That is the integral along the curve CA equal to 0. Then for the total integration along the curve C, that is a triangle, that is integral over C y square dx minus x square dy equal to integral over AB plus integral over BC plus integral over CA, that's equal to 0 plus minus 2 by 3 plus 0, that's equal to minus 2 by 3. Okay. Then we have next question. If f equal to 3xy I cap minus y square j cap, evaluate integral over C f of r dot dr, where C is the curve in the xy plane, y equal to 2x square from 0 0 to 1 2. That is, we want to evaluate integral over C f of r dot dr. Here the vector function f equal to 3xy I cap minus y square j cap, and the curve, the smooth curve is in the plane xy plane, y equal to 2x square from 0 0 to 1 2. Here y equal to 2x square is a parabola, and we only need from the part from 0 0 to 1 2. Okay, here we are going to do this by two methods. First one is parametric representation, and another one is the as usual method. Okay, listen, first one, the parametric representation of the curve C is r of t equal to t 2t square 0, that is t I cap plus 2t square j cap plus 0 k cap. Why z becomes 0? Only we consider in the xy plane. Okay, here we substituting x is equal to t. When x is equal to t, then y equal to 2 into t square. So t I cap plus 2 t square j cap, and 0 less than or equal to t less than or equal to 1. How becomes the variation of t from 0 to 1? That is, here look here, we taking x is equal to t. Okay, x is equal to t, and in the plane x varies from 0 to 1. So t varies from 0 to 1. Then we get x of t equal to t, y of t equal to 2t square. How we know r of t in the general expansion of r of t equal to expression of r of t equal to x of t I cap plus y of t j cap plus z of t k cap. So comparing this, we get x of t equal to t, y of t equal to 2t square. So we want to find f of r of t. Then substituting x is equal to x of t, y equal to y of t in the vector function f, we get 3x of t, y of t I cap minus y square t j. That's equal to x of t we have t, y of t equal to 2t square. Substituting we get 6t cube I cap minus 4t raised to 4 j cap. Then we want to find r dash of t. Okay, that's equal to I plus 4t j cap. Then taking the dot product and integration, that's equal to integral over c f of r dot dr equal to, we have the expansion in the parameter representation, that is equal to integral a to b f of r of t dot r dash of t dt. We have a and b, that is the variation of t from 0 to 1. Then integral 0 to 1 6t cube I cap minus 4t raised to 4 j cap dot r dash is equal to I plus 4t j cap dot dt. Taking dot product of f of r of t and r dash of t, we get integral 0 to 1 6t cube minus 16t raised to 5 dt. Then taking the integration of t cube and t raised to 5, we get 6 into t raised to 4 by 4 minus 16 into t raised to 6 by 6 from 0 to 1. After calculation, we get minus 7 by 6. Okay. Then we have another method, that is in the xy plane we know z equal to 0. Okay, then r of t equal to x I cap plus y j cap, then dr equal to dx I cap plus dy j cap. Then we want to find integral over c f of r dot dr. Then substituting r in f, that's equal to integral over c 3xy I cap minus y square j cap dot dr equal to dx I cap plus dy j cap. Then that's equal to taking dot product, then integral over c 3xy dx minus y square dy. Okay, then partially we integrating, that's equal to two parts. Okay, 3 into integral over c xy dx minus 3 integral over c y square dy. Okay, here we have x terms with respect to dx, we are integrating, then here we present y. So we know the equation of y, the curve equal to y equal to 2x square, then substituting y equal to 2x square here, then we get 3 into integral over c x into 2x square dx minus integral over c y square dy, since y equal to 2x square. So taking 2 outside, then we get 6 into integral 0 to 1 x cube dx minus 0 integral 0 to 2 y square dy by 0 to 1 and 0 to 2. We know x varies from 0 to 1 and y varies from 0 to 2 in the parabolic curve. Okay, then integrating we get 3 by 2 minus 8 by 3, that's equal to minus 7 by 6. Okay. Next, we have another method of question, that is, another form of questions. Okay, if f equal to, that is, if f equal to x square plus y square plus z square the whole square, evaluate integral over c f of r dt, where c is the helix r of t equal to cos t sin t 3t, that is cos t I cap plus sin t j cap plus 3t j cap, k cap, 0 less than or equal to t less than or equal to 2 pi. That is, we want to find integral over c f of r dt. Here given the function, scalar function f equal to x square plus y square plus z square the whole square, and the curve r equal to it is a helix, that's r equal to cos t I cap plus sin t j cap plus 3t k cap, and t varies from 0 to 2 pi. Okay, then we want to substitute r in f and integrating with respect to t. Okay, that here r of t equal to x of t, y of t, z of t, the general notation, that's equal to given cos t sin t 3t, that is cos t I cap plus sin t j cap plus 3t k cap. Okay, here x of t equal to cos t, y of t equal to sin t, and z of t equal to 3t. Then we want to find f of r of t, that is substituting in f, we x is equal to x of t and y equal to y of t and z equal to z of t. Then we get f of r of t equal to f of x of t, y of t, z of t. We know equation of f equal to x square plus y square plus z square the whole square, then x of t square plus y of t square plus z of t square the whole square. we have x of t equal to cos t, y of t equal to sin t, z of t equal to 3t. Then we get cos square t plus sin square t plus 9t square the whole square. Then we know cos square t plus sin square t equal to 1 in trigonometry. Okay, then we get 1 plus 9t square the whole square. Then therefore the integral over c f of r dr equal to integral 0 to 2 pi f of r dt, that is t varies from 0 to 2 pi. Then f of r dt equal to integral 0 to 2 pi 1 plus 9t square the whole square dt. Then a plus b whole square expansion we substituting and calculating, we get t plus 6t cube plus 81 t raised to 5 by 5 from 0 to 2 pi. After calculation substituting 2 pi and 0 for t, we get 2 pi plus 48 pi cube plus 2592 by 5 pi raised to 5. Okay. Next we have question f equal to xy I cap x square j cap. Evaluate integral over c f of r dot dr. That is, we given the vector function f equal to xy I cap x square j cap. We want to evaluate integral over c f of r dot dr. Here the curve c is a quarter circle from 2 0 to 0 2 with the center at 0 0. We given the smooth curve is a quarter circle, only the quarter part of a circle whose radius is 2, because it varies from 2 0 to 0 2. Okay, center at the point 0 0. Okay, start. Here the path of integration c is the quarter circle from 2 0 to 0 2 with the center at 0 0. We know the center of a circle at the origin and whose radius is r, then whose parametric representation we have r cos theta, r sin theta, where theta is the angle. Then here the center is 0 0 and points is 2 0 and 0 2, then the radius is 2. Then the parametric representation of the circle is r of t equal to 2 cos t I cap plus 2 sin t j cap, and t varies from 0 to pi by 2 because we only need the quarter part of that circle. Okay, then r of t equal to 2 cos t I cap plus 2 sin t j cap. Thus x of t equal to 2 cos t and y of t equal to 2 sin t. Okay, here we get x of t equal to 2 cos t, y of t equal to 2 sin t. Then f of r of t equal to x of t, y of t, x square t. Then substituting x of t equal to 2 cos t and y of t equal to 2 sin t, then we get 4 cos t sin t 4 cos square t, that is equal to 4 cos t sin t I cap plus 4 cos square t j cap. Then also we want to find r dash of t, that is equal to minus 2 sin t I cap plus 2 cos t j cap. Then substituting, therefore integral over c f of r dot dr equal to integral a to b f of r of t dot r dash of t. We have f of r of t and r dash of t. Then directly substituting integral 0 to pi by 2, where t varies from 0 to pi by 2 because only considering the quarter part of the circle. Cos 4 cos t sin t I cap plus 4 cos square t j cap dot minus 2 sin t I cap plus 2 cos t j cap. We taking the dot product, then we get integral 0 to pi by 2 minus 8 sin square t cos t plus 8 cos cube t dt. Here we taking 8 outside and cos t outside, then we get 8 into integral 0 to pi by 2 minus sin square t plus 1 minus sin square t cos t. Okay, here we taking cos t outside, then we have cos square t. We know cos square t equal to sin square t 1 minus sin square t because trigonometric equation, that is sin square t plus cos square t equal to 1, then cos square t equal to 1 minus sin square t. Okay, that is in 8 into integral 0 to pi by 2 minus sin square t plus 1 minus sin square t cos t dt. That's equal to 8 into integral 0 to pi by 2 1 minus 2 sin square t cos t dt. Here we substituting sin t equal to u because the derivation du equal to cos t dt. Okay, that is in the above integral we put u equal to sin t, then we get du equal to cos t dt. Okay, then the limit also change. When t equal to 0, sin 0 equal to 0, that is u equal to 0. When t equal to pi by 2, sin pi by 2 equal to 1, that is equal to u equal to 1. Then therefore the integral over c f of r dot dr equal to 8 into integral 0 to 1 minus 2 u square. Instead of sin we substituting u, that is 2 u square into du. That's integrating, that is 8 into u in minus 2 u cube by 3 0 to 1. Substituting the values 1 and 0, then we get 8 into 1 minus 2 by 3 minus 0. Okay, that's equal to 8 by 3. Okay.